Welcome. In this video, we're going to be learning about gears, forces, and mechanical advantage. So we're going to cover what is mechanical advantage, what are gears, and how do gears allow us to adjust the mechanical advantage. Let's go ahead and answer that first question. Mechanical advantage is the advantage gained by the use of a mechanism in transmitting force. So more specifically, it's the measure of a ratio of output force, like the force to turn a wheel, to the input force, such as the force of a motor in a system. We're going to talk about what that means in examples as well. Now, gears allow us to adjust the mechanical advantage. Gears are circular discs that have notches in them, known as teeth, that mesh together. So in the IQ kit, you have 4 gears that come as part of it: a 12-tooth, 24-tooth, 36-tooth, and 48-tooth. So gears are classified using the number of teeth on the gears. A gear train is a mechanism that's made up of 2 or more gears in a gear train. So there is a driving gear and a driven gear. The driving gear is the gear connected to the input force, such as a motor. The driven gear is connected to the output. So we're going to talk about everything in terms of input and output, driving and driven. So how do gears allow us to adjust the mechanical advantage? There are 3 different scenarios to look at. So first, we have a 1-to-1. So these are 2 36-tooth gears connected together in a gear train. And this allows you to reverse the direction of rotation. So if I spin this piece, this will be my input, this will be the output, so driving, driven. If you watch, the gears are spinning opposite of one another. So my input gear is spinning clockwise. My output gear is spinning counterclockwise as you go through, or vice versa. So that's if you want to change the direction of your output force. There's no mechanical advantage here, just direction. And because it's the same number of gears for input and output, this is also classified as a 1-to-1 because your ratio is the same, 36 to 36, so 1-to-1. Next, you have an increase of speed. So here, that's where you have a large gear driving a small gear. So in this example, I have a 48-tooth as the input driving gear, and I have a 12-tooth as the output driven gear. So right here, I'm going to go ahead and spin this input, and let's watch our output. You can see our output beam is spinning substantially faster than our input. It's actually spinning 4 times as fast because for every 1 rotation of the 48-tooth gear, the 12-tooth gear has to go around 4 times. So that's where you get that increased speed. And that's a mechanical advantage. So it's faster, but you'll actually have less output force. In opposite, you have increased torque. So torque is the measure of force that can cause an object to rotate about an axis, also known as rotational force. So you'll see more of an output force here. So if I spin the small gear, the 12-tooth, as my input, and watch the 48-tooth as my output, or driven gear, you can see I have to spin the 12-tooth gear 4 times before the 48-tooth gear makes it all the way around. So the speed is slower, but it also allows the output force to be increased, which is also known as an increase in torque. So how does this allow us to better make robots? Now, this can help you change your design to increase mechanical advantage, depending on the scenario. If you're trying to design a race car that you want to be fast, it's going to have to be light and can't move as much weight. So you might have less torque, higher speed, which is a big gear driving a smaller gear. If you want to push or carry something heavy, you're going to need more force or more torque, but you're going to have to go slower, just like a semi-truck would carry cargo. So a small gear driving a big gear. All three scenarios, increased torque, increased speed, or reversing the direction of rotation, the input doesn't change. So the amount of force going in, whether that be from a motor or my hand in these examples, doesn't change, but the output changes. This is very helpful because it allows you to multiply or reduce the amount of output force without having to adjust the input or then you can change the direction of the force because of a one-to-one. Reversing direction also allows me to keep the directional force the same as the input, but allows the direction of the output using gears to change. So you can use all of this together to design your best robot, whether you're looking for increased speed, increased torque, or a reverse in direction, using mechanical advantage, which again is the advantage gained by using a mechanism to transmit force. A gear is a circular disc that has those notches in them known as teeth. And finally, gears allow us to change our mechanical advantage so that you can design your best robot. Have fun.